Hello, and welcome to the MEF 3.0 SASE Services Overview. My name is Neil Danilovich, editor of the MEF SASE Services Specification. SASE Service Attributes and Service Framework, MEF 117, is the industry's first standard defining SASE services. It describes the requirements for a session-aware overlay service that uses policy to determine the secure networking for and the application of security functions to subscriber sessions, irrespective of location of the subject actor or the target actor, thus providing secure, authenticated, and authorized access from anywhere to anything. SASE is part of the MEF 3.0 Global Services Framework. The MEF 3.0 Global Services Framework has three pillars. The first is the service category, which is where SASE lies in the subcategory of cybersecurity, along with zero trust. Other service category definitions could include carrier Ethernet, IP services, network slicing, or mechanized edge. The second pillar is automation. This is where the framework's APIs and SDKs are defined in order to provide the lifecycle service orchestration for the services category. The third pillar is the test and certification. This is where service providers certify their products against the service definitions in the service category. Technology providers certify their equipment against those service definitions. Both service providers and technology providers certify their APIs against the LSO standard of APIs, and professionals can certify their knowledge against both the services categories and the LSO automation. Global cybercrime costs over $1 trillion per year in damages. This is why cybersecurity is at the forefront of every CTO and CISO's vision for transforming the enterprise network. The vision is that a single cyber policy can be instantiated across the network, regardless of where it is, or in on-premise, or in the cloud, or remote. The previous model was a disaggregated services model. Networking was separate from security, which was separate from cloud services. This provided major complications as networking had their own policies and constructs, security had their own policies and constructs, and cloud had yet their own policies and constructs. Tie points were utilized typically in order to interconnect these, and policy was fragmented and was difficult to maintain and assure that a single cyber policy was instantiated at all points across the network. SASE services helps to simplify this model. The concept is a SASE service combines wide area network connectivity and security functions in one service to grant a subject actor access to a target actor for a given session. This access is based upon the subject actor's identity, context, role, risk score, behavior, and the policy sets up security sets to determine which security functions apply. Actors are either users, devices, or applications. Obviously, IoT devices want to access the network. We have many users wanting to access the network, both on-premise and remote. And we have lots of application-to-application connections needed to be supported by modern enterprises today. Access to the SASE service is independent of the location. This could be on-prem, remote, in the cloud, doesn't really matter which region of the world, and it's authorized using the policy set by the subscriber. Now, it should be pointed out that this access is access granted through the SASE service. I want to differentiate that from the access of the actual target actor. For example, I, as a user, want to access my Facebook account through my company's SASE service. The first thing I do as a subject actor is I access this my company's SASE service. I get authenticated, I get authorized. Then I indicate that I want to access Facebook. My service looks through the policies and determines whether or not, first of all, I'm actually allowed to go to Facebook. Well, let's just say for the argument's sake here, I am allowed to get to Facebook. So now I get to Facebook, at which point now I get the login page where I enter my Facebook credentials. SASE service is not part of the Facebook credentials. The Facebook would determine whether or not I have the proper credentials to get in. Once I'm in, now Facebook has a lot of things that I can do. I can post, I can download, I can video things, I can instant message, you know, I can play games, right, off of Facebook. Now, that's what Facebook allows me to do. My SASE service, though, might restrict it. Perhaps I'm only restricted to viewing certain things because I need to keep some updates and see what's going on with certain people on Facebook. But what it doesn't allow me to do is necessarily post or download content. That's where the SASE service can restrict what I'm able to do from the target actor. So this is where you start to see the vision and the breadth of the capability of the SASE service. We'll get into this more as the conversation continues. The components of the SASE service are the following. SASE sessions, obviously everything is a session. Actors are what is instituting those sessions and what is being acted upon. The actor access connection is the connection on how you get from the actor to the service. The SASE edges are the components where certain functions are stored. The policy endpoints are the points at which the SASE policy is applied. Identity access management function is the function that deals with authenticating and authorizing the access of actors to the service, as well as controlling what type of actor access connection is needed for each one of the SASE sessions. The SASE forwarding policy is determining the performance and forwarding characteristics of the IP packets for that session. Security functions are the policy components that determines which security functions apply to the individual security session. To the individual session. And this could change based upon how the session is behaving. When that goes into the session lifecycle management, because we have to continuously monitor to determine if things have changed and whether or not more security functions or a different policy now applies, which then leads into notifications for the fact of to tell you when things have changed and if any security events have occurred. So the SASE service edge is the set of components that make up the SASE service. And in between the service edge, we have what we call our session forwarding policy, which is typically predicated on SD-WAN, but could be any other type of network connectivity from EVPN to VPN to even Ethernet services, as long as we can arbitrage the sessions across the network. The cybersecurity policy determines which security functions apply to the given sessions. The continual monitoring will monitor the different concepts and context values and important parameters to determine if anything has changed or if the policy needs to be reevaluated. The actor access connection is how we control the information and make sure that sensitive information is secured in a manner after it leaves, before it comes to and after it leaves the SASE service. All of this can be instantiated on premise, in the cloud, or at the mechanized edge. It does not matter where it's placed. It can be in any one of those locations. And we'll see that as we get to the use cases later on in the presentation. SD-WAN and SASE. The current specification for SASE recommends that the session forwarding in between two SASE edges should be an SD-WAN service defined by MEF 3.0. This is to assure that the application flow specification as defined in the SASE service aligns with a service that is predicated upon an application flow specification. However, this is not a hard requirement, but it is highly recommended. Keep talking about sessions. So let's see, what is a session? Well, a session is a set of IP packets determined by a session specification and a state. And the reason we do these two different is the session specification gives me the list of actors, me and my brother. We want to talk. The application flow specification says what type of application we're using. In this case, we're going to do a Zoom call between me and my brother. Now, as we know, Zoom is made up of video, of voice, and of collaboration. So my session specification, or sorry, my application flow specification could be as simple as just the video portion for Zoom, or it could be more expanded to include the video, the voice, and the collaboration all in one specification. Depending on how I define that will be help to start with the session. But now the reason we include session state is I might talk to my brother in the morning and I might talk to him in the afternoon. While those are both me and my brother, both the same application, they occur at different times. So every session has to have a unique session ID, and the state goes through initial, operational, possibly reevaluate, and finally terminal. Initial being when I first start to call my brother. Operational is when a policy has been authorized for that call to proceed. A policy has been applied, and it's operating, and we're working. Reevaluate is when something has changed and says that, hey, we have to look at it and make sure the policy is there. Reevaluate doesn't always mean that a new policy is applied, but you reevaluate for that set. This could either be event-driven or it could be time-driven. And the final one is terminal, right? We talked about it. I talked to my brother in the morning and I talked to my brother in the evening. Those are two separate sessions. Obviously, a SASE policy is applied for both, and they could be different because I could be in different locations, could be time of day. The service edges are what, as I said, what makes up the SASE service. And we have two SASE edges when we talk about an individual given session. That is the edge that is closest to the subject actor, the one that is initiating the access. We call that the subject SASE edge. And that's what controls the actor access connection to the subject. Okay. We also have one that is in close proximity to the target actor, and that would be called the target SASE edge. Now, it should be noted that these determinations of subject and target are based upon a given session, because while this edge may be the subject edge for my Zoom session, it could literally be the target edge for an application that is trying to update my computer. So depending on which way you are doing this, which way we are doing this will determine which one is the target and which one is the subject. The actor access connection, we talk about this a lot. The service inside it is completely secure, but a lot of the information that is coming and leaving the SASE service is of a secure and secretive nature and needs to be protected. Therefore, the subject actor access connection is what we use to make sure that the information that is being transmitted to or transmitted from the SASE service is protected. These can be physically implemented in a variety of ways. Could be a campus LAN, could be a wireless network, could be Wi-Fi, could be 5G, many different, and it could be a concatenation of all of those, where you went to a campus LAN and then to a wireless network. The key point here is it's the policy for a given session that determines what type of actor access connection is allowed. Security functions are a prime part of the SASE service. The SASE service needs to be able to inspect the traffic and make sure that none of the traffic is going to places where it shouldn't be, or is using the wrong protocols, or contains malware. So there are a bunch of security functions defined in the current specification. These include the middle box function, which is used to decrypt encrypted flows, such that the other security functions can look at the unencrypted traffic and determine whether or not the session should be forwarded. We have IP port and protocol filtering to make sure the appropriate IPs, ports, and protocols are utilized. DNS protocol filtering to determine which of the DNS messages and protocols should be transmitted back and forth. We have domain name filtering to determine which domains that the subject actors should be allowed to access. We have URL filtering to determine which URLs and which content the user should be able to access and which he shouldn't be able to access. And finally, malware detection and removal, which will assure that there is no malicious content associated with the session. SASE incorporates a zero trust framework. This means that we must authenticate the actors. You have to figure out their identity and figure out whether or not they're authorized to use the service. Now, MEF 117 mandates that all subject actors be authorized and authenticated. It recommends that target actors should be authenticated and authorized. Now, people always ask me, well, why do you only recommend target actors? Well, the problem is some of the target actors are in the control of the consumer, in the subscriber, or they are under the control of the service provider. In both of those scenarios, the subscriber has a contractual set to be able to say, hey, I want to be able to authenticate that target actor. However, some of the target actors just exist on the internet, or some of the actors are outside of what the business deems critical. Here's where I'm going to go with this. Let's assume that my company is a financial company and they're not really worried about Facebook. They allow me to get to Facebook, but they're not really worried about authenticating that Facebook is Facebook. So what that means is if they decide that they don't want to authenticate an actor, that doesn't mean they have to give me access to it. That just means that their policy has to have a decision into it that says, is he or is he not allowed to get to the target actor that can't be authenticated? So the policy itself determines whether or not you get there. Now, the beauty in SASE is I can define my policies differently. For authenticated target actors, perhaps I don't add as many security functions. However, for unauthenticated target actors, perhaps I add on a lot more security functions. Perhaps in the continual monitoring, where I have different criteria that need to change, perhaps I have a lot more criteria being monitored for target actors that aren't authenticated versus targets that are authenticated. The key here is, though, we're always monitoring the SASE session to make sure that things haven't changed. If they have changed, then we go back to policy management and the policy endpoints to determine if a new policy needs to be applied. The key here is every session is authenticated, authorized. The identity of the subject actor is authenticated and authorized. The policy determines which actions can be done. So whether or not I can actually upload files to Facebook or not upload files to Facebook, right? That's part of there, even though Facebook would allow me to do it. And this is what incorporates the SASE framework. Like I said, SASE policies. They have to include a bunch of stuff. And there's what is going to determine which subject actors can get to which target actors, under what conditions, what they can do if they're allowed to get to that target actor. And the way that it's done is by using the following policy criteria. Identity and access management policy attributes. This is two parts. One, authenticate and authorize the given actor, typically subject actors, but could be used to authenticate target actors. But it also needs to secure the actor access connection. Based upon policy, does it need to be encapsulated? Does it need to be encrypted? Again, if for whatever reason the actor access connection does not live up to what it needs to be, then the policy would look at it and determine whether or not, one, more security functions need to be applied, or two, whether or not access should be terminated. The second set is a context policy attributes. This would include time of day, location, risk score, a bunch of different things. What type of network I'm using, my roles, right, within the company. These policy attributes will be used to influence whether or not I'm actually allowed to access the network, and whether or not I'm allowed to access the target. An example might be that I'm only allowed to access GDPR data while I'm in the European Union. So when I travel to the United States and I try to access the company and I try to access GDPR, well, my contact says I'm not in the right location, so I'm not allowed to access it. So access would be denied. Security policies are the set of security functions. And as we discussed before, it could be a single set of security functions for every session, or it could be differentiated, meaning that certain sessions have certain sets of security functions applied. And even a given session, depending on how it goes through its life cycle, security functions may be added or removed depending on what is satisfied. The session forwarding policy attributes determines how the session is forwarded across the service and the performance requirements thereof. The monitoring policy attributes are the list of attributes of the important things that need to be monitored in order to change the state. Remember, one of the states for a session is reevaluate. So if one of my critical pieces of information or criteria changes, then my state changes to reevaluate. The policy endpoint that sees that IP packet under that state would then reevaluate the policy, possibly changing the policy to a different policy, or possibly terminating the session because the change in attribute was so severe that the session no longer can stay. Notification policy attribute is the final one. This is what sets the notifications to the subscriber about changes in policy, as well as security events. As I just said, my attribute changed so bad that we terminated the session. That would be a notification to the subscriber that my session has been terminated. SASE has several use cases. The generic one is just, we have remote users, we have on-premise devices. So we have an edge that's actually on-premise where the customer is. We have users accessing it via the internet. And then we also have accessing cloud services. This is just a generic set. Inside it, as you can see, we have different functions. We have identity and access management that's inside the edge along with policy endpoints. We may or may not have security functions on an individual edge, but we definitely have security functions inside the whole SASE service. You'll notice that identity and access management needs to use an identity provider. Now, there are three options for the identity provider. The identity provider can either be provided by the service provider because the subscriber contracts with the SASE service provider to be the identity provider, or the subscriber itself has its own identity management, and so it is being the identity provider. Or the subscriber has contracted with a third party, such as Okta identity provider, which would reside in the cloud. The key here is that the SASE service has to use one of those providers, and one of the service attributes is the list of identity providers for the service. You can see that we have the actor access connection that is being utilized to connect to the edges from each one of these locations for each one of those actors, and that's what's going to secure the communications. So generically, that's how it works. If we were just doing an all on-premise, then all my edges would be on the premise. I would have a network between the two. The actor access connection would go over whatever the local area network is at each one of the on-premise locations. And then we would use the forwarding policy to determine which underlay connectivity service to get between the edges. We'd have either the IDP inside this or the IDP someplace, either it's inside the service or could be third party. When we have the security functions either being applied at the devices or in the cloud. How the security is done inside the cloud would be up to the service provider to determine. Remote access is where the users are coming in and connecting from an internet connection into the SASE service and either going to an on-prem subscriber network location or to a cloud service that is owned by the subscriber. It's basically the same as the previous model, except that in this case, the access into the service from the remote locations is across the internet. But notice we still use the actor access connection to control that connection. So it really doesn't matter whether this is the internet or it's a local area network. Security, of course, is going to be defined across this for these sessions based upon the policy that is applied. And given that this is remote access, it's possible that maybe more security is applied on this than the previous use case, which was on-premise. The last use case is the SASE cloud service, cloud delivered service. In this case, both accesses are internet service into the SASE service. And where this one differs quite a bunch is that since it's all inside a cloud, we don't really talk about the session forwarding because it's edge to edge in the same cloud. And here the subscriber network on the left side connects to the SASE service, and then packets are evaluated, security functions are applied, access or authorization of the session is done, monitoring of the session is done, and then it goes to the target actor. But it's all done over the internet. So in summary, MEF 117 provides a secure service definition that integrates both security and networking constructs. It's driven by policy and adopts a zero trust framework. So integrated security and networking, policy driven, zero trust. In a nutshell, that is the SASE services definition, MEF 117. Here are more resources on how to get started and getting involved with the SASE service. You can go to mef.net/SASE. You can download the standards off of mef.net, MEF 117 for SASE and MEF 118 for zero trust. And there's a bunch of articles and podcasts. With that, I'd like to thank you for your time and have a good day.